Welcome to the deep dive from the Artificial Quant by TPQ.
Great to be here.
You're here because you want the real insights, yeah.
Mm-hmm.
Cutting through the noise on AI and finance.
Absolutely.
Today, we're tackling something pretty big. Google DeepMind's AlphaEvolve just came out.
Yeah, it's a significant release. We've been looking into it.
So we'll unpack it, what it is, why it matters for AI generally, and crucially for our audience, its potential in quant research and development.
Exactly.
We're not just summarizing the paper here, we're pulling out the core stuff you need without getting lost in the weeds.
That's the plan. AlphaEvolve is it's fascinating. It blends LLMs with evolutionary computation. Some really striking results.
Okay, AlphaEvolve. The name hints at evolution, progress. What's the simple take?
Right. Think of it as an evolutionary coding agent. That's DeepMind's term.
An agent that codes and evolves.
Yeah, basically. It's built to help state-of-the-art large language models get even better, especially on tough tasks.
Like what kind of tasks?
Things like open scientific problems, big research questions, but also really practical stuff like optimizing computational infrastructure.
So an AI improving other AIs or even optimizing systems, how does that actually work?
Well, it runs this autonomous pipeline. It uses LLMs.
Multiple LLM.
Yeah, the pipeline of them. They iteratively improve algorithms by changing the code directly.
Okay.
And the evolutionary bit is key. It's driven by feedback, constant feedback from one or more evaluators.
Feedback, right. What kind of feedback and what does the evaluating?
So the evaluators are usually automated. They're set up to test the code generated against specific criteria, really rigorously.
So if it's an algorithm, speed, accuracy.
Exactly. Speed, accuracy, maybe resource usage. If it's math, it checks for correctness.
Got it. Generate, test, learn, improve. A loop.
Precisely.
The paper mentions some impressive applications inside Google already. What did it actually do?
Yeah, some good examples. One was developing a much more efficient scheduling algorithm for their data centers.
Okay, that's huge at their scale.
Definitely. Resource savings. It also found simpler ways to design certain hardware accelerator circuits. Functionally the same, just simpler.
Wow.
And maybe the most meta example, it actually sped up the training of the LLM that AlphaEvolve itself uses.
That is meta. An AI helping train itself faster.
Right.
But here's what really caught my eye. Discovering novel algorithms better than the state-of-the-art in math and computer science. Tell me more about that.
Yeah, this is probably the headline result. It developed a completely new search algorithm for multiplying two 4x4 complex valued matrices.
Okay.
It does it using only 48 scalar multiplications. Now, the reason that's such a big deal is that the previous best, Strassen's algorithm, it had been unbeaten for 56 years in this specific setting.
56 years.
56 years. Think about that. A foundational algorithm, unchallenged for over half a century. AlphaEvolve didn't just tweak it. For this case, it found something fundamentally better.
That's genuinely groundbreaking. And the quant implications. Faster matrix multiplication could speed up so much. Pricing, risk.
Absolutely. Anywhere those ops are done millions of times.
So how? What's the core idea that lets it do this?
The magic, if you like, is combining evolutionary computation with the code writing skills of top LLMs.
Right.
It works best with the potential solutions. Maybe a math object, maybe a practical heuristic can be checked automatically, evaluated for quality.
That automatic evaluation again, it seems crucial. Why?
Because it's the objective judge, right? LLMs can generate tons of code, some good, some not so good.
Some just plain wrong, I imagine.
Exactly. So the automated execution and evaluation acts like a reality check. It filters out bad ideas and, importantly, tells the system why something worked or didn't, guiding the evolution.
And it's not just fiddling around the edges. The paper says it can find solutions quite different from where it started.
That's a key point. Because the LLMs understand feedback, they can make bigger leaps. They explore a wider possibility space. So AlphaEvolve can land on solutions that look very different structurally and functionally from the initial set. That's where the potential for real innovation comes in.
Now, DeepMind had FunSearch before this. The paper positions AlphaEvolve as a big step up. What are the main differences? Table 1 was useful there.
Yeah, Table 1 lays it out well. A big one is scale. FunSearch mostly worked on small code snippets, like 10, 20 lines maybe.
Right.
AlphaEvolve handles whole code files. Hundreds of lines. It evolves the entire thing.
Okay, much bigger scope.
Much bigger. Also, language flexibility. FunSearch needed super fast evaluation. AlphaEvolve, well, It can handle evaluations taking hours, using parallel processing, accelerators.
So it can tackle more complex, slower to evaluate problems.
Exactly. And it uses far fewer LLM samples overall, surprisingly.
Yeah.
Thousands versus millions for a fun search.
Interesting. Less brute force, more intelligence.
Sort of. It benefits hugely from the latest, most powerful LLMs like Gemini. Fun search didn't really get better with bigger models.
Yeah.
Plus, the prompts are much richer. AlphaEvolve gets more context, detailed feedback. Fun search prompts were pretty minimal.
So like upgrading from giving vague instructions to providing a detailed briefing.
That's a good way to put it. And it can optimize for multiple things at once, not just a single score like Fun search.
That multi-metric optimization seems really relevant for finance. Speed versus accuracy, risk versus return.
Precisely.
You mentioned the reliance on automated evaluation earlier. That's still a limitation, right? What can't it do?
Yeah, that's the main constraint mentioned. Basically, if you can't define success clearly and measure it automatically, AlphaEvolve isn't the right tool.
So no problems needing human intuition, subjective judgment, or lots of manual lab work.
Exactly. Needs that clear, computable goal.
Okay, let's get into the components. What makes AlphaEvolve work under the hood?
Sure. There are several key parts working together. First is task specification and evaluation. This is where you, the user, define the problem, the what.
Right.
And critically, you provide a Python function called evaluate. This function takes a potential solution and scores it based on metrics you want to maximize.
So you set the target and the measuring stick.
You got it. Second, there's an API for evolution. This is neat. You can take your existing code and just mark blocks you want AlphaEvolve to work on with special comments. Hashtag evolve block start and hashtag evolve block end. The code around those blocks gives context. Your initial code inside can even be pretty basic.
That sounds really practical for integrating it into existing quant libraries or models.
Exactly. Makes it much easier to apply. Third is flexibility and abstraction. It's not just editing raw text.
Okay.
It can operate differently depending on the problem. It might evolve, say, functions that build solutions, or it could evolve whole new search algorithms, or even evolve solutions and the search algorithms together.
So it adapts its approach.
Yeah, different levels work better for different tasks. Constructor functions might be good for finding symmetric solutions. Bespoke search might be better for non-symmetric ones.
Clever. What else?
Then there's prompt sampling. Because it uses top-tier LLMs, the prompts can be incredibly rich.
You mentioned richer prompts earlier.
Right. They can include loads of context problem details, equations, code examples, even pointers to research papers. They also use randomized formatting sometimes, just to mix things up.
Keep the LLM on its toes.
Kind of, yeah.
Yeah.
Encourages diverse outputs. And crucially, the prompts include results from past evaluations. What worked, what didn't, what the scores were.
Learning from experience.
Exactly. And there's even meta-prompt evolution, where the LLM suggests ways to improve its own instructions.
AI coaching itself on how to be more creative, that's something else.
It really is. Next up, creative generation. This uses an ensemble of LLM's Gemini 2.0 Flash and Pro, specifically. They digest all that prompt info and suggest improvements.
How do they suggest them?
Usually as a diff. Showing the code to remove or change and the code to add, search and replace. Makes it very clear.
Yeah, I saw that format in the paper. Easy to follow.
Then comes evaluation, which we've talked about. Automatic assessment using that user-provided evaluate function.
Right.
It uses smart tricks like evaluation cascades to quickly ditch bad ideas and parallel processing to speed things up. And again, it handles multiple scores simultaneously. Maximize speed and accuracy, for example.
Very useful.
And finally, evolution. It keeps track of all the solutions and their scores in an evolutionary database.
Like a library of attempts.
Yeah, but a smart one. It uses techniques inspired by things like MAP elites and island models, basically ways to explore widely and deeply, finding diverse high-performing solutions without getting stuck.
Okay.
The whole thing runs as a distributed pipeline. It's an asynchronous Python system built for high throughput, lots of samplers, lots of evaluators, all working together.
It's like a seriously engineered piece of kit. Okay, let's bring it back home. For the quants listening, the folks at the Artificial Quant, what are the real-world impacts, the potential applications here?
Right. This is where it gets exciting for you. That faster matrix multiplication work. That's not just abstract math.
No, definitely not.
Developing those better tensor decomposition algorithms, beating Strasson's in that 4x4 case. That has direct implications for optimizing the heavy number crunching in quant finance.
Risk models, derivative pricing, HFT.
Exactly. Anywhere matrix math is a bottleneck. The speedups could be significant. Imagine faster backtests, more complex models running live.
It could change the game for certain strategies?
Potentially, yes.
Yeah.
And look at the other Google examples. Optimizing data center scheduling.
Mm,
Okay, maybe not directly finance, but the principle of optimizing complex computational resources is universal.
true. We all have compute constraints.
Then enhancing Gemini kernel engineering, speeding up AI model training, optimizing TPU circuit design that hints at maybe AI-designed hardware for finance down the line,
Specialized quant chips. Interesting thought.
and optimizing compiler code like flash attention that's optimizing a core part of modern AI models, which are increasingly used in finance. The fact it can improve already optimized code is telling.
Yeah, squeezing out more performance even after compilers have had a go. And doing it fast, you mentioned kernel optimization, going from months to days.
Months to days. That kind of acceleration in optimizing core infrastructure or even specific models that could drastically shorten development cycles in quant R&D.
It really could. The paper also mentioned ablation studies. What did they show?
Basically, they switched off different parts of AlphaEvolve one by one to see what happened.
Right.
And it confirmed that all the key pieces matter. The evolutionary approach, the rich context in prompts, the meta prompts, evolving whole files, using powerful LLMs take one away, and performance drops significantly.
So it's the whole package, the synergy between the parts.
Exactly. It's a well-designed system where the components work together. It's not just one trick. And comparing it to previous work like FunSearch or AlphaTensor, it really does feel like a big step forward in automated algorithm discovery.
Okay, so summing up, AlphaEvolve, Google DeepMind. It's this novel blend of evolution and advanced LLMs. And it's achieved some genuinely impressive results, breaking long-standing records in math, optimizing real-world computer systems.
Absolutely. It shows AI isn't just processing data anymore. It's actively discovering and improving the tools, the algorithms themselves.
And for you, our listener, the quant professional, the potential is pretty staggering. Think about automated algorithm discovery for trading, for risk, for portfolio construction, optimizing your actual code base automatically.
Yeah, it forces you to ask some big questions. Could systems like this find trading strategies we haven't even conceived of?
Or new ways to manage risk.
Exactly. How quickly could we develop custom quant models if AI like AlphaEvolve was helping build and optimize them?
It paints a picture of the future where AI is much more of a creative partner in quant innovation, not just a tool.
I think that's right. AlphaEvolve is a really compelling glimpse of that future. If you want the full technical detail, definitely check out the paper, alphaevolve.pdf. It's worth the read.
It really makes you think about how these technologies will reshape the field. Thanks for joining us for this deep dive.
My pleasure.
Lots to ponder there. Until the next time, here at The Artificial Quant.